Okay.
Ja, om jag har ost hemma så blir mögelost ost.
Good morning. So let us continue the lesson. But before, there's something that I have to adjust. I write an equation here for you. I want you to work on it. Then I will, after 5 minutes, I will start solving that. So solve the following equation. We talked about sines and cosines. We haven't talked about tangents yet. We will talk about that today, and then everything will be finalized. So we want to solve this equation. Cosine. So let me write 60 degrees minus 3x, okay, is equal to square root of 3 over 2. When I say solve, I mean find all possible values for x so that this becomes true, okay? Yes?
Do you know the answer?
No. But let us try to solve this together. One thing Maximilian actually mentioned last time, I think it deserves to be noted here, is that might be some of you are being tempted to actually write cosine of this minus cosine of that. Of course, that makes the problem a little bit simpler, but that's not true, okay? In Math 4, we will learn the formulas for these. So remember that if you have sine or cosine, it doesn't matter. If you have sine of A plus B, if you just naively write sine of A plus sine of B, that is wrong. Yes, that's not correct. And then you can check it, for example. If I give you A to be 30 degrees and I give you B to be 60 degrees, if I ask you to calculate the left-hand side of this expression, it becomes sine of 30 degrees plus 60 degrees. 30 degrees plus 60 degrees is 90 degrees, so that's different. So this means that you have to add and then take the sine. This means that you have to take the sines first and then add. And this is not true that these are equal. Okay? So here, sine of 30 plus 60, I have to add first. I added, and then take the sine. If you remember, sine of 90 is just 1. But if I ask you to calculate the right-hand side, to the right-hand side, you have to calculate sines first, and then add them. But I have these numbers in my memory. Sine of 30 is 1 over 2. Sine of this is the square root of 3 over 2. But when I add them, it becomes 1 plus the square root of 3 over 2, which is not equal to 1. So for now, we will learn. The formula for this becomes a little bit more complicated, and we will study that in Math 4. But for the time being, I want you to understand that this is not true that I can write cosine of this minus cosine of that. Okay, so that's something that I want you to know. Okay, but then you have to visualize that unit circle. So do you remember? You have a fixed number. If you want to have cosine of a box equals to a number k, then you find your k somewhere on the x-axis, positive, negative, it doesn't matter. But the point is that you draw a vertical line, yes? And then there are 2 points corresponding to that angle. So one possibility is this angle. The other possibility is this bigger angle, but I told you that I myself prefer to write it with the negative sign angle. So if one of them I don't know is theta, the other one is minus theta. So what theta is cosine inverse of k. Yes. If you don't like, you can write it with 360 degrees minus theta. But it would be easier if I write theta and minus theta. So that's the point. So what you do when you want to solve, you have to somehow imagine that. And I told you that it is better because the formula is not in the formula sheet. You can write the formula in front of your eyes, yes? So you can say that, okay, cosine of some box is equal to k. According to this idea, I realize that what is inside the box is, of course, cosine inverse of that k. But that is not enough, because there is another one, which is the negative of that. So you write plus or minus. And then I told you that it doesn't matter how many full rounds you go around, you will come back to the same point. So this means that you have to write n times 360 degrees, and write n belongs to 0. So this is something that you visualize, or I don't know, sketch it on the paper, and try to understand the formula, and then when you found the formula, you can use it here. But this is now playing the role of your box here. So what I can say is that my box, which is 60 degrees minus 3x, is equal to plus or minus cosine inverse of my number, which in this case, my number is the square root of 3 over 2. But then you have plus n times 360 degrees. You mentioned that what n is an integer. But this is now, we can go forward a little bit. You can use the table which is given, or if this number is not a famous, you can use your calculator. Probably this will appear only on that part that the calculator is allowed. If this appears in the part that the calculator is not allowed, because the formula sheet is allowed from the beginning of the exam to the end, this means that this number is a famous angle. And if you have studied a little bit, at least you know that this is a famous angle. Okay? So if you do that, you will get cosine inverse of that is 30 degrees. Yes? Okay, so then I have plus 30 degrees, minus 30 degrees. I have to solve it with both of them. So I consider two cases. One case with the positive sign. So this becomes 60 degrees minus 3x is equal to 30 degrees plus n times 360 degrees. But then I want to find x, so I move 60 to the other side. It becomes minus 3x. It becomes 30 minus 60, which is minus 30. And then I have plus n times 360 degrees. And then what you need to do, you have to divide everything by minus 3 to make x alone. If you do that, it becomes positive 10 degrees. Yes? But then it becomes negative n times 120 degrees. Yes? One thing, I don't know, this is a little bit Math 4 lesson, but this is completely correct, not wrong. But might be if you go to the faucet, you will see that they will give this one to you with positive sign. You might think that, okay, might be I have missed the minus sign. You double check and you see that no, you have done it right. But still, the answer in the faucet is positive one. That is possible. Why? Because that is important to understand what is the meaning. If you see this, this is the answer. But I can simply write the answer as this, 10 degrees plus another number n times 120 degrees. Because you know that there is no God-given rule to say what you name it. So if you see that in the faucet they have it with positive sign, it means that what they have chosen for n is opposite to what you choose for n. Yes. So for example, the point is that at the end, this formula and that formula will generate the same angles. Yes. For example, if you put n equal to 0, this will generate 10. If you put m equal to 0, it will generate 10. So far, so good. But if you put n equals to 1, it will generate minus 110 degrees. But if I put here 1, it will generate 130 degrees. You might say that, okay, they are not the same. No, they are not the same, but if you are patient and then completely assign every integer to this, you get all angles. And if you do the same thing here, you will get all angles, but then you compare the angles, the set of these angles are completely the same. For example, can I generate minus 110 from this formula as well? Yes. But instead of putting m equal to 1, I have to put m equal to minus 1, which is also allowed, because we say that these numbers are integers, so they take positive values as well as negative values. So this means that If I start giving positive values for n, I will get negative values. If I put negative values of n, I will get positive values. But in this case, the scenario is different. If I put positive values, I get positive values. If I put negative values, I get negative values. But the values that I get at the end are exactly the same. That is the point. So that is, it doesn't matter if you write the formula like this or you write the formula like this. Or even you can just say that, okay, I switch n to minus n. You can also write it with n. But be careful, this n and that n are different. Okay, so that's what I'm saying. I mean, in the exam, I don't know, but if you just write that, that's okay with me. So that's not wrong, that's complete. But usually I'm telling you that you might get this answer, but when you go to the faucet, you see that they have written it with the positive sign. You might think that you have done some mistakes, but that is not a mistake, yes? Okay, is that understandable? Yes? Okay, so that is one thing. If you prefer, I myself prefer to write it with the positive sign. So you can write it like that, but if you keep it like that, that's also okay. Okay, let me just elaborate a little bit here. So might be you solve an equation. I will talk about that later. Okay, let me complete this. But this is one scenario. Another scenario is that I have to take the negative sign. So the negative sign is, again, I have to rewrite 60 degrees minus 3x is equal to minus 30 degrees plus n times 360 degrees. And then the same thing, yes, I have to solve that. So I move 60 degrees to the other side. It becomes minus 3x. Minus 30 minus 60 is minus 90. And then you have plus n times 360 degrees. And then you divide by minus 3, so it becomes positive 30 and minus n times 120. That's also another answer. Another group of answers. Infinitely many answers are there. Infinitely many answers are here. Yes? Can I change minus n to n? Again, the answer is yes. So that would be the full solution of this trigonometric equation. Let me, for example, to understand this a little bit better, let me ask you to solve this very, very simple question. So sine x equals to 0. Okay, I'm trying to look at those angles whose sine is equal to 0. Okay, that's very, very trivial, but let me just try to use the formulas. Yes, do you remember what was the formulas for sine? Yes, if you want to have sine of a box equals to k, let us generate the formula in the scratch paper. So if this is k, but because sine is related to the y coordinate, I find k value here, but I draw a horizontal line, then I will get two intersection points. This is provided by your calculator, but there is another angle that I have to consider, is this angle, which is 180 minus that one, yes? So there are two angles. So what should I do? So I generate the formula. So the formula tells me the box is equal sine inverse of k plus what?
N times 300.
N times 360 degrees, or 180 degrees minus sine inverse of k plus, for example, a same letter. In principle, you should choose another letter, but let me just use n again. So you generate the formula immediately in a scratch paper so that you can have the formulas in front of you to be able to use it. Okay? So if I want to do that, this is playing the role of my box here. So what is the answer? So x is equal to sine inverse of 0 plus n times 360 degrees. Yes? But then sine inverse of 0 is 0, so it becomes n times 360 degrees. That is a group of solutions. Another scenario is 180 degrees minus sine inverse of 0 plus n times 360 degrees, yes? And then sine inverse of 0 is 0, but this becomes 180 degrees minus n times 300 plus n times 360 degrees. That is completely okay. So you get two groups of solutions. But my point is that most of the time, if you solve this one and go to the faucet in the books, you will neither find that one nor that one. You see that they have written this answer. Only one answer. Yes? Again, I want you to understand you have done nothing wrong. I want you to understand the two packages that you found is equivalent to one simple formula. And that is clear, isn't it? If you want to understand this, this tells you that where are those points? This formula tells you that the angles that you are interested in are multiples of 360 degrees. For example, if I put 0, I get 0. If I put 1, I get 360 degrees, which is exactly this point again. If I put 2, I get 720 degrees, which is exactly this point again. Even if I put negative values, I will get the same point. Yes. So it means that if I ask you how many angles are there are infinitely many angles, of course. They are different, but all of them are corresponding to the same point on the unit circle. But then if I ask you where are these angles, so let us just do that. If I put 0, I get 180, which is here. If I put 1, I get 180 plus 360 degrees, so I go back here. Yes? I don't know if I put two revolutions and then you go back here. So this means that at the end you understand that I have two groups of solutions. One is on the right hand side, the other one is on the left hand side. And that is what this formula is giving you by its own, yes? Because if I put 0, I get this point. And if I put 1, I get 100 degree, which is this point. And if I put 2, it becomes 360 degrees. I will return to that point. So this means that these two, they are equivalent to one simpler single formula. So the point is that you should consider all possible points on the unit circle. So if you can find a simpler formula to do the job for you, it's better to write the simpler formula. Okay? But I think this is not very, of course, when they talk about these things, you should also know about these things. But I think the main focus of these things will be in Math 4, not in Math 3C. But I mean that here, if I give you this, and if you write these answers separately, that's correct. But even if you understand that you can combine these two into a simpler single formula, that's also better. Yes? Okay, so let us now go to the last part of the lesson. And that what happens if I have equality for, I want to solve tangent, trigonometric equations involving tangents. That might be, there is one point that you have to be careful about. So my question is that if I give you tangent of theta equals to k, we want to find theta. Of course, the first thing you can do is just to use the calculator to find one angle. Yes, so theta is tangent inverse of k. But that's not the whole story. It will give you one possible angle. So immediately you can tell me there are infinitely many more. Yes, what are they? Even if you don't imagine anything, what are they? Because theta will be an angle. It will be an acute angle, for example. You get something here. Assume that this is theta. But even in this case, you can hook up infinitely many more. Yes?
Is it plus n times
360 degrees. So if that's the angle, it's clear that I go one full round here, I will get the same thing. But the whole point is that if you go one full round, then you are ignoring infinitely many more solutions. Because there are infinitely many more, but not here, exactly in the opposite point. Okay? So I want to convince you that these are the only points, and you have to consider this one as well. So then it means that if the calculator gives you an angle, there is another angle that the calculator will not give it to you, and that is how much? Is from here to here, which is
180.
180 plus theta. Yes. So it means that there are two angles. One angle calculator will give it to you. The other angle calculator cannot give it to you. You have to visualize this after I told you why this is true. Yes?
Right. Why is it 180 plus theta, not minus?
No, plus.
Yes.
No, because from here to here is 180, I have to continue theta degrees more. Yes? Okay, but why first of all this works? Do you have any idea? So, this point has two coordinates, x and y. Okay, can you tell me what are the coordinates of this point then?
Minus x minus y.
Minus x and minus y, because they are reflections of this point through the origin. Yes? Is that understandable? Okay, now if I ask you what is the tangent theta, you would say tangent is y coordinate divided by the x coordinate. And if I ask you what is tangent of 180 degrees plus theta, you will go to the end point of this angle, and then you divide the y coordinate of that point by its own x coordinate, which is minus x. But you see that these two minus signs are cancelled, then I will get the same thing back. So it means that tangent has a different property. So in sine and cosine, in order to get the same value for both of them, I have to go 360 degrees. But for tangent, if I go 180 degrees, that also works. Because even though x and y will change, but they change in a way that the division will be the same. Yes? So this means that when you want to answer this question, you have to consider two angles. Okay? So one angle is what? That angle provided by the calculator. There is another one that you have to imagine this picture to be able to understand. So what is the other one? 180 degrees plus tangent inverse of k, yes? So this will given you by the calculator. There is another angle that is involved. Okay, but these are not the only ones, of course. As before, I can add how much? A multiple of 360. And I can also add a multiple of 360, yes? So this is this one or that. Yes? Understandable?
Sure.
But you can of course write this, that is not wrong, but this is one of those occasions that these two can be combined into one simpler formula. Okay, so that is not wrong if you write it in two, but we can simply combine it into one single formula. And that is understandable here. Because when I start from here, this formula every time takes me one full round. Of course, I will end up the same point. Yes? But if I can somehow go to this point and then go to this point, that will work. So this means that either you have to consider two separate formulas in that form, but there is another way. Can you tell me what? I start from here, but instead of adding a multiple of 360 degrees, which will take me back to the same point, yes?
Plus 180? Or
Yes,
n
I
times
would
180?
say n times 180.
Yeah.
So this is something, so you need to analyze this. I don't know. This is the formula for tangent, and it is much more compact and simpler to remember. But probably a little bit harder to deduce, yes? Because you need to have some argument behind it. Okay, so this is the formula that we will use. So if I tell you that tangent of theta is equal to k, and I ask you to find the theta values, you will tell me that theta is tangent inverse of k, and then plus n times 180 degrees rather than 360 degrees. If you write 360 degrees, you are losing these angles. Okay? If you insist to write 360 degrees, you have to write two formulas. But it would be much better if we just write one formula. Yes? You will see that later in Math 4, we say that these functions are periodic functions. But the period of sine and cosine is 360 degrees, but the period of tangent function is 180 degrees. We will study that later. Any questions? Okay, but now we can solve some problems. The lesson is finished, actually. So, tangent, for example, we can have 2x is equal to 1. We want to solve this equation. So the first thing that you do, you take this one as your unknown, and the unknown 2x is tangent inverse of 1. But if I am using this formula, I don't need to write two formulas, I just write 180 degrees here. And then this 2x becomes tangent inverse of 1 is a famous angle, I have it in my memory, so it's 45 degrees. And then plus n times 180 degrees. And then you want to find x, so you divide everything by 2. This becomes 22,5 degrees. And then this becomes n times 90 degrees. Yes? But let me try to see some better problems in the book. I think the examples in the book are good. Let's see, is there something that I have to complete or not? When I see at the exercises, might be this is the case in Math 3C. In Math 3C, probably you don't need to work with the most general formulas, yes. So let me try to solve one of these for you. For example, they have considered this, I don't know, a double star problem. So let me start from that. So to be honest, they are taking these problems that I solved here for you a double star problem. Okay, so might be I went a little bit fast because I told you that these are Math 4 problems. Now they appear in your book, but they are A-level questions with 2 stars, okay? But I think that that was not hard at all, so that's good. So let me try to... Abundance of erasers. So, let me solve this one, but they are also asking something more that I haven't done this on the board yet, but you can do it yourself. Let us see. They have asked you to solve this equation, solve the exact values, but they have given you an interval. Okay? So they are not asking for all possible angles, because in that case you always have infinitely many, but they are asking it. It doesn't mean that you don't need to know these formulas. You have to solve it first using the formula and then do something more, okay? So, because when I see also the solutions in the book, they are also following the same thing, okay? So, the equation is this: cosine x over 2 minus 45 degrees is given to be minus 1. Okay, we want to solve this equation, but we are not, for some reason, we are not interested in all infinitely many solutions. We are only interested in those solutions to this equation which lie on this particular interval. And that is more reasonable, because usually, even though in trigonometry we have angles larger than 360 degrees, whatever, but still we have a good relationship with the angles from 0 to 360 degrees. That's good. Okay, let us solve that one. But now, I don't want to repeat everything again, but if you check your notebook, we started with the problem of cosine exactly at the beginning. So I will follow that one. Do you remember what was that? So this will be your box, and that would be your angle. So what I write is x over 2 minus 45 degrees is plus or minus, you can refer to your notes, okay? But this you have to generate on the exam yourself. So minus 1 and then plus n times 360 degrees. At least you have to mention that what n is somewhere. This is something you can also imagine. Can you tell me what is cosine inverse of minus 1? Because cosine is related to the x-coordinate, yes?
180.
180, yes? Because 180 is on the left-hand side, and the cosine is the x-coordinate, and the x-coordinate of this point is -1. But I don't know. This number is also famous, you can probably find it in the table. Okay, so this is 180 degrees. So this becomes x over 2 minus 45 degrees is equal to plus or minus 180 degrees plus n times 360 degrees. But be careful. It is better to split it from here, okay? Of course, one more step, you can move it to the other side and write plus or minus. We can do that. So x over 2 becomes, I move minus 45 to the other side, but there is a plus or minus sign left, and there is 180 degrees plus n times 360 degrees. If you want, you can also multiply by 2 everything. So this becomes 90. This becomes plus or minus. This becomes 360 degrees. And then finally, this becomes n times 720 degrees. So I would say that if you understand what is going on, the hard part is the first one. You need to imagine and generate the formula again in front of you so that you can use it. But the rest of it, I don't think it's hard. But this is not, I have to separate it, yes? Because plus sign will give me 450, negative sign will give me minus 270. So I have to consider both of them. Okay, so what should we do? We can write it in 2 steps. So number 1, x is equal to, let me take the plus sign first, so it becomes 450 degrees plus n times 720 degrees. And then another scenario is x equal to, taking the negative sign, 90 minus 360 is minus 270, and then you have plus n times 720. So I mean, in my examples, this is finished, okay? But in the example in the book, they are asking you not for all infinitely many answers. They are only interested of the answers on this interval, okay? So then you have to go number 1 and remember that this number is an integer. For example, n equals to 0 gives me 450. It is an answer, but not an acceptable one in that one. So you don't need to put 0. Should I increase n? It's pointless, yes? If I increase n, I even get higher and higher values. But you have to also consider negative values. So you see that for n equals to 0, n equals to 1, etc., etc., not in this interval. Okay? So it means that I need to go to negative values. Let us check. If I put n equals to minus 1, what happens? It becomes 450 minus 720. Is it acceptable? No. It's negative, yes? And then I don't need a negative. So it means that none of the first group answers are acceptable at all. So just forget about this. Not in the interval. Yes? And I hope that you agree there is no point if I lower it even more, because it becomes more negative. Yes? So no answers on that particular interval is obtained from here. Yes? Is that clear?
Yes.
But now I have to check the other one. What do you think about the other one? So let us start from 0. Okay, 0 is not acceptable, because if I put 0, I get negative value. So it is not acceptable. Okay, 0 is not acceptable, but let me put 1. Is 1 acceptable? No, because 720 minus 270 degrees is larger than 360. But I don't want larger ones. This means that there is no point that increase n. Okay, so let us go to negative values. There are no answers actually. Yes?
Yep.
There are no answers there. So no answers. So this equation has infinitely many solutions. If I ask you, give me two of them, you put 0 here, you give me 450, for example, you give here and you give me minus 207. These are answers, of course, these are solutions, but none of them are in this interval. Okay, none of them is in this interval. So let me check, by the way, is that correct?
Hopefully.
50, 66, yes. I don't know, usually. $50.66. Yeah. Part B, which is this part, there are no solutions. Yes? And it was clear. So I mean, this part, the hard part I would say, is to find the general formulas. And then the rest of it, if it is wanted, you have to put the numbers one by one, so that to see how many of them are in your interval and separate them. Otherwise, that is very simple. Is that clear now? Okay. Yes. So let me write another one that's also double star problem. I want to start. You will start working on it. I don't know how I can implement, because you know that GeoGebra is by default in the radian mode, which we will study later. I want to see how can you understand this problem from graphical point of view, and then you can solve the other one in the meanwhile. Don't waste your time. There are good questions in the book, I think. Yeah. So if you really know how to solve them, I don't think you will face any problems in the exam. So this one, at the same interval, but the equation is this: sine. So this one I want you to start from scratch, generating the formulas in the scratch paper, and use those formulas that you have generated. Of course, after a while, if you can memorize it, you really don't need to reproduce it again in the exam. Okay, but anyway, this is equal to 1/2. I want you to solve this equation, but I'm only interested in the solutions on this interval. In this interval, on its long preposition, I think, for interval. So I hope that you could solve the problem, yes? So how we should solve the problem here? So we generate a formula first, but we have already done that, so let me just use the formula. So there are two alternatives. Here, this will play the role of our box here, so this means that 2x plus 40 degrees is equal to sine inverse of this number 1/2, but plus n times 360 degrees. But there is another one, or 2x plus 40 degrees is what? 180 degrees minus this angle. And then we have to solve that. But this is a famous number that I have it in my memory. So this is 30 degrees. Okay, so if that is 30 degrees, we can do it in our head, yes? Let us just do it in our head. So 30, I move 40 to the other side, it becomes minus 10, and I divide everything by 2, so it becomes minus 5. But this should also be divided by 2, so it becomes n times 180 degrees. So you have to write n in its equal, okay? But this number is still 30, but 180 minus 30 is 150. You move 40 to the other side, it becomes 110. You divide by 2, it becomes 55, yes? That is also another group of solutions. Yes?
Shouldn't that be m?
Yeah, in principle you can write m, but because there is or, it doesn't matter if you same this. But if this is and, you have to change it. Yes.
And by the way, if you forget to write n, is like
No, in principle you have to remember. Don't forget. Yes. In the national exam, if that happens, then probably you lose some points.
Oh.
Yeah. Okay. But I'm interested in the answers in this interval. So let us call this group number 1, group number 2. So in group number 1, can I start with I don't know. probably 0 is good starting point. Okay, so let me start with 0. But this will not give me an acceptable answer, yes? This is not acceptable. It's not in the interval, it's not acceptable. Otherwise, minus 5 degrees is also correct. But then, I hope that you agree there is no point for getting to negative values. It becomes more negative. So let me just jump up and then write 1. Is it acceptable?
Yes.
Yes. It becomes what? 175 degrees. So we put this in a box. N2. N2 is also acceptable. Yes? Because if you put 2, it becomes 360 degrees. But because that angle is minus 5, it becomes 355, which is acceptable. But do you think, is it good to go higher?
Nope.
No. That is the only 2 solutions that you get here. And then we go to the second group. In the second group, I think it's also good to start with 0. If I put 0, what do I get? Acceptable. 235 degrees. That's acceptable. So let me also go to a negative value if it is acceptable. No, it's not acceptable. Yes?
Also,
Yes?
if you put 0 instead of n, wouldn't that be 55?
Ah, yes, thank you. I put 1. This is n equals to 1. That's acceptable. So
If n is 0, then that
so
would.
let me keep the order. So that is 235 degrees, and that is 55. Thank you. Both of them are acceptable, yes. But I think there is no point to go higher. So how many solutions you get?
4.
4. If you want to be in this interval, there are only 4 acceptable solutions. So you see that these double star problems are also very, very simple, not hard. Okay. Okay. So yeah, probably I can think about GeoGebra later, and then there should be a way. I did it before. I don't know how to switch it back. We can probably see some examples from the national exam, but then it would be hard to simultaneously. Okay, so do you have your laptops in front of you?
Yes.
If you already have a question, it might be better if I start answering your question. Otherwise, we can pick up I don't know, a random national exam, and then we start solving those problems. Okay. Okay, so what question number 21? This is the national exam.
Yes.
2014. So Kaisa, if I can pronounce her name, Kaisa has a thin iron sheet that measures 2.4 meters by 1.2 meters. She will make a wind shield for her rabbits out of the iron sheet, yes?
Mm-hmm.
And then you see the picture, everything is there, okay?
Yeah.
So the wind shield will consist of a roof, 2 sides and a back. Kaisa will cut out 2 squares from the iron sheet and then fold it into a wind shield. Yes. Kaisa wants the wind shield to have as large volume as possible. Assume that the pieces she will cut out have the length x meters, where x is somewhere between 0 and 1.2. See the following figure. Determine x so that the wind shield will have as large volume as possible. So which part of the exam is it? Is it D?
I think it's C without calculator. No,
With
it's
D.
D.
No,
It's
I don't
D.
think this should be. So this is D part.
Yeah.
Digital resources are allowed. Okay?
Yes.
Okay, so that is the question. I need to write some numbers down because I will not see it later. So what we have is something like this. So let me. No, that would be very hard to record both scenes. Yes. So you have something like this. Here is your back. Let me write B for back, and then this is side. Yes, and that's also side. And then you have this roof. Let me call this one roof. Here something like this, and then this is given on the picture. This is X, this is also X, X, and X. Yes?
Yes.
And then from here to here is 1.2 meters, everything is in meters. And from here to here is 2.4. Okay. And now we know that X is somewhere between 0 and 1,2. Yes, that's also understandable, yes, because you cannot have X more than that. But the point is that you want to make the volume of this windshield as large as possible.
Mm-hmm.
Okay, so how we should do that? First of all, I need to find a function for the volume. The target function that you want to optimize is a volume. So let me call it V. It's a good name for a volume, yes? But you have to write this V as a function of your variable x here. Okay? So it means that I want to write the volume as a function of x. But what would be the volume of this one? I hope that you agree that when you do this windshield, it becomes a rectangular cube. And the volume of the rectangular cube means the volume of the base multiplied by the height. Okay? But then what will happen? Can you tell me if I fold them up like this and I bring this roof down, okay? So what will happen for the volume? Yes? The height becomes how much? The height,
1.2 minus 6.
yes, 1.2 minus 6. That would be the height. But what would be the area of the base? What will be the base? You can imagine, yes, that was also in the picture. So what will be the base?
2.4 minus 2x.
2.4 minus 2x is the length of the rectangle. So 2.4 minus 2x
Times 6.
times, let me see if that is correct. Yes, times x. Yes, times x. So this is the volume.
Why is the last x put in here?
Well, because you want to find a volume. Yes, you need to imagine, I don't know, there will be a rectangle down there.
Yeah.
The rectangle, this from here to here is 2.4 minus 2x.
Yes.
But this one is also x, yes?
Okay.
Because when you fold it up, this will become x. Yes? This x will go out actually. Like this. That's the one. And then you know what to do. An interval is given, you have a function, you want to optimize your function. In this case, you want to maximize it. But this function, you don't know how to differentiate because you don't know the product rule. So there is one way to do it for you. Yes?
Multiply
all of
the
them.
derivative.
Yes.
Expand.
And that's a little bit, not annoying because you have access to the calculator. It's annoying for me now, okay? So what should I do? I have to multiply 1.2 times that. So if I do that, it becomes 2.88. Is that right? Can calculate this?
It is.
It's okay. And then I'll multiply that. It becomes minus 2 comma 4x. And then again minus 2 comma 4x. And then this becomes positive x squared. And another x. Okay, let me simplify this now. So v of x becomes equal to, I multiply x in, and let me write them in an organized way. So x squared times x, it gives me x cubed. I write it first. It doesn't matter, by the way. This is how much, this one and that one, it becomes 4 comma 8 minus 4 comma 8. But x, another x is multiplied, it becomes x squared. And then I have 2 comma 88 multiplied by x. So that is my function. Yes?
So like, in the second row, shouldn't the last x be 2x squared?
Oh, thank you very much. This one.
Yes.
Yes, thank you very much. 2x squared. So this means that what will happen, it becomes 2x cubed. And if any other flaws, you can check.
Looks right.
That one is correct, that one is correct, that is also correct, then plus 2x squared, yes. And then I have another x, so that's correct. Thank you very much. Okay, but what I have to do, I have to take the derivative now.
Yeah.
So the derivative is equal to 6x squared. The next one becomes minus 9.9,6x. And the next one becomes 2,88, yes?
Yep.
And this is annoying, yes, because that's what is now solving a quadratic equation with very bad numbers, yes. But anyway, you have access to the calculator. So b prime of x is equal to 0. This gives me this equation equals to 0. But that's the ABC formula, yes? So I will write it down and I will ask for your help, yes? I don't know, I usually prefer to simplify as much as possible, but is there any point to simplify here? So can I divide everything by 6, I think? It becomes easier. If I divide this by 6, it becomes 1,6. If I divide that by 6, it becomes 1,44 divided by 3. But is it divisible by 3? Definitely yes. What is the answer? 28, yes? So 2 comma...
No, it's
0.
0.48.
What?
0.48.
48, thank you. So it becomes plus 0, comma 48 equals to 6. But of course, if you have calculator, you really don't need to bother about simplification that much, because the numbers, even the numbers are big, you put them there, yes?
Yes.
Okay, and then we put them in the ABC formula. So x becomes negative b, which is 1,6 plus or minus 1,6 squared, and then I have minus 4 times this times that, which is 1,92, yes? Now please check my calculations, okay? And then divide by 2 times 8. But then it becomes 1,6 plus or minus, this number to power 2 is 2,56, and then minus 1,92, yes? And then divided by 2. So if you subtract them, how much is that? 8. Okay, so that's also a good number actually. 0.64 divided by 2. And this is 0.8 now, yes? So then it becomes 1,6 plus or minus 0.8 divided by 2. So I told you that I always prefer to simplify, but that is, you really don't need. You have to, even by the way, when you simplify, even if you want to put it in the calculator, it's still easier. But you don't have to, because it is in the calculator allowed part. So then I will have 2 answers, yes? 1.6 plus 0.8, which is what? 2.4 divided by 2 is 1.2, am I right?
Yes.
Yes.
And then subtraction divided by 2 gives you 0.4. Meters, yes, it's meters.
Yes.
But of course, 1.1, 2 is not acceptable. Yes, because it is not in that interval. And it is understandably not in that interval, because if x is 1.2, nothing is left actually. Yes, it will fall apart. So, but I don't know, you have to check the question, because you know that there is no minimum thing for this. Yes, because there are no minimums for the volume. But in principle, if you want to follow it mathematically, you have to calculate the volume at the end points, which is not needed here. If I put 0, this becomes 0 because of the last x. If I put 1, 2, this one becomes 0, the whole expression becomes 0. And it is understandable, the volume at those extremes become exactly equal to 0. But then, this means that I have to put this one number here. So what was the question, do you remember? They are asking about x, or they are asking about the maximum volume?
No, it says determine x.
Determine x so
Determine
that
x so that the
okay, that's
shield
the
have the
determine
largest
x. So
volume
that is
possible.
the x.
That's the
That's the
answer.
x.
Yeah.
But if they ask you about the maximum volume, you can also check, I don't know, if they really want to motivate this number is the maximum number, not a minimum number. Then what you have to do, I don't know which one they are using, because you can use the derivative tests to check that this is indeed a maximum.
Yes.
But if you remember, we also learned maximizing or minimizing the continuous function on an interval. You don't need those tests. You just find the values and then put them in the function. The maximum value to get is the maximum of the function. The minimum value you get is the minimum value of the function. So if we have done everything right, hopefully this is the correct answer. 0.4 is the answer that we're supposed to do. Any questions? Understandable? So how many points were there for this question?
3 C points.
Okay, so it was not that hard according to them, so 3 C points, yes.
Can you please solve the question 24?
Of this exam?
Yes.
Okay, let me first change the view. Okay, so you were asking about question 24, and now you can see it on the display here. You can also see it in your own display. So the figure shows the graphs of the functions f and g. We see these graphs. It holds for the function h that h of x is f of x minus g of x. Determine h prime of 2. Yes? And this has 2 a points. Okay. So let us go back to the board now. Unfortunately, I need the picture here every now and then, so I have to switch back and forth. I don't know what will happen for the recording. It might be better if I project it here, but let me see. First of all, if I want to solve that problem, h of x is given to be f of x minus g of x, yes? And then you are supposed to find h prime of 2. That's the question. So what you need to do for finding the derivative of any function at a point, you have to take the derivative of the function first. So this means that I take the derivative of this function. But on the right-hand side, I have the difference of two functions. If I want to take the derivative of the whole expression, you know that you can do it separately. Yes? Understandable? Okay, and then you want to calculate h prime of 2. So h prime of 2 becomes f prime of 2 minus g prime of 2. So the only thing that you need to do is to go to the picture, to the graph, and try to read this number from the graph and that number from the graph, yes? And the derivative means the slope of the tangent line to the graph at the point whose x-coordinate is that number, yes? Okay, now, if I go back here, I don't know if we can do that on this picture, but probably we will be able to do it. So if I go back here, so now look. Okay, the function f is a line, so the slope is always the same. So it doesn't matter where do you look at it, but you just read the slope of this line. So what is the slope of this line? Can you understand that? So if I want to calculate the slope, you need to find those points that are passing exactly through two grids in this line, not just approximations, yes? So one thing, if my eyes are actually seeing correctly, one point that I see is on the graph and I can read the coordinates is the y-intercept, yes? It is 4. Okay, so that is one point.
Yeah.
So one point is, remember, 0 and 4. So let me write it here. People cannot see what I'm writing, but anyway. 0 and 4 is 1 point. Can you see another? Help me to find another point. I think 2 and 1. Yeah, do you agree? I also see 2 and 1. Okay, so this is 2 and 1, and that one. Okay, so here I can calculate actually the slope. I can come back to it. But the hard part is, this I really don't know what they mean. Because what you have to do, you have to go here on the x, g of x at point 2. If you go up there, I don't know how can I explain this to you. There is a point whose coordinate is 2 and the y coordinate is 3. Do you see that?
Yeah.
So at that point, you need to draw a tangent line and try to estimate. That is the bad part. I don't know how much you have to estimate. You have to estimate this slope by drawing a reasonable line. Yes, do you have any?
It says determined h of 2, so I immediately thought that we had to do it with perfect accuracy. But you mean that it should say estimate at h of 2.
I don't know. Might be we can see the solution. But what I understand from this, there's no other way that I can do it.
This is strange.
Or might be we can talk about f of x minus g of x, but I don't think that is also better. It's not an easier option. We can go and check the solution, of course. Yes, but I don't know. Can you see what is going on? My impression is that the slope is 1. I don't know how much do you agree with me.
Slope of
The slope of the tangent to the graph of g of x of that point, at that point. First of all, find the point 2 and 3. Look at with the point 2 and 3 on the graph. And then, I don't know, take your ruler and try to draw a tangent line there. Yes. And I would also appreciate some of you go to the solution and see that if you are doing this right.
Yeah.
Are we?
Yeah, but the slope of tangent is not 1.
So that is very hard. I mean that you need to draw a tangent, which is a little bit tricky how I can draw the tangent. Yes? This I really don't like the question. Because for example, when I draw a line, when I draw a graph here for you and I say that, okay, draw a tangent line here.
Yeah.
How should I expect you to draw a tangent line that I don't know. I can also see the solution myself to see, but is it the same thing that they are doing? This is not a good question, because of course I need to also read this bedomning to see how much if you mistake, because it might be, of course, if you get a negative value for the tangent line, it means that somehow you have to visit your eyes, so check your eyes, yes? There is no way that you get a negative value.
You get a point if you write the situation,
Yes?
and then the other point you get if you write the exact answer.
Pardon?
If you write the answer exactly, then you will get both points.
Så som jag ser det.
Otherwise you will get just only one point. for
But what
writing
is the
this.
exact answer?
it's example. It's
Yeah,
not an exact number. It's that, for example, you can get this number 0.65,
Yes?
67. And
Yes?
for example, you can get like another number.
Yes?
So it depends on where you choose that point of tangency.
So it depends. If it is reasonable, you get the points.
Yeah.
That's good. In that case, that's good. Yes.
But what's reasonable? It doesn't say here within what range you would hit the point.
Maybe
So
the
what's
point is
reasonable?
you
Is it
find
up to the
that
teacher?
write the tangent.
Yeah, but what if I estimate the slope to be, well, I don't know, 1? You said that you estimated it to be 1.
Because I wanted to be very roughly, so it's not 1. What is the number?
0.67.
So
It's an
2 over 3
example.
is basically what
It's 2 over
they're
3.
saying. They're saying 2 over 2. But would 1 be accepted? That's my question. Would 1 over 3 be accepted?
No, because
how big of an
I-
error can you have?
I agree with you. I don't like the question because of these things. Yes, but might be I was a little bit careless when I said 1. Yes, I don't know. If you have a ruler, probably you understand, because 1 happens if it goes from that point to this exactly the opposite corner. Yes, and if it doesn't go exactly to the opposite corner, it's a little bit smaller than 1. Okay, but the point is that when you want to correct, the first thing is that you might get confused in the exam session. But if you are not confused, I was confident that this should be the answer, yes, then I would try to estimate it reasonably, and then leave the exam session. Then that would be my duty to correct your papers, and then I see understandable. I will probably give you the points. I will read the bedoning except, but it is reasonable. They are not asking you unreasonable things, except this word determine, and I think that's the translation of bestäm in Swedish. I think if you see the Swedish version, they're also using that word.
I can look.
Yes, But then in that case, yes, I would say that it would be better to have a rough, educated estimate.
How would you interpret when they say, for example, 0.67? Would you interpret it as like what error would you allow when you were grading, or if you were grading?
To be honest, I haven't thought about that. But I don't know. Is there any explanations there?
I mean, it
I
only
think
says
the point is you should find that you have to draw a tangent.
Yeah.
And if you can draw a tangent,
I might be. Don't worry. But I mean, I agree. The way that they have stated the question, even when I told you that when I was doing some national exam in this calculator allowed part, there was an integral. I was trying to solve the integral. Okay. But then I realized because it was not at the level of high school, that integral. But then I realized that when the calculator is allowed, you can just punch the whole integral in the calculator. So so remember this, by the way, in the calculator part, I don't understand. If you want to calculate the derivative, some calculators can calculate the derivative for you. So then you can punch this there and then find the answer. It's not very clear. Because I was thinking when you say calculator is allowed, arithmetic calculations are allowed. So I was trying to solve the integral, then put the numbers in my calculator. But then when I saw the bedömning, it was actually the whole integral that you have to punch in the calculator.
But will we get a calculator that can handle that? Because I don't know if mine could.
Don't worry about these things. Let us see how it goes.
They pay to win.
We have
They
to-
pay to win.
Yes.
In the Swedish one, it says bestämd.
Ställ upp.
So it means determine. And determine
The determine is more specific.
Yeah.
Bestämd is like find something. Determine is like find the one.
Okay, on Monday we also continue. I would recommend you to go through the questions. It would be better. And then if you have questions, then we go through your questions first. But if you don't have any questions, I pick random examples.